It was perfectly respectable to imagine that there was a civilization on Mars. There was only one Genesis in our solar system. But we know that material moves from Mars to Earth. We have Martian meteorites here, and from Earth to Mars. And so then, I suppose, the story becomes, where did life begin? It is certainly possible that life began on Mars and was transferred here to Earth. I suppose in that sense, we're Martians. What a discovery that would be. So paradoxically, if you're interested in how we came to be here, the answer might lie up there.
Why colonizing Mars would be no fun at all. Professor Brian Cox reveals that living on Mars would be no fun and argues that humans cannot inhabit the red planet anytime soon because it's simply too harsh, casting doubt on Elon Musk's dream of colonizing Mars. So why does Brian Cox believe humans won't colonize Mars? And what dangers exist on the red planet?
We find signs that life existed on Mars, and that life is very different to the life we see here on Earth. It has a different biochemistry. There was a different genesis. That would mean that life began separately in two places in our solar system. And that will tell us a tremendous amount, because it will tell us that we can assume that wherever the conditions are right, life begins. That will be a profound discovery. It will change the way we think of our universe, because it will mean that we are in a living universe. It should change the way you look at those points of light in the sky. Many of them, most of them, have planets around them, and I think we'll be able to assume that a good number of them are living worlds.
Mars isn't fun. The idea of building a new civilization, I just don't see it, Professor Cox told I don't think you're going to have hundreds of people on the surface of Mars, and if they did, it's probably centuries ahead. Why would you? It's hard. It's not a fun thing to do. It's really not. It's hard enough, and it takes a certain kind of person to be on the International Space Station for 6 months. You speak to any astronaut and they'll say it's a wonderful experience, but it's not easy. You have to train for it, and you're an hour away from the Earth. Just psychologically, if you get ill on the space station, you can get on a Dragon spacecraft and come back. You're only a couple of 100 miles away, and it's still a challenge for the human body and mind. Even with the moon, you're only a couple of days away. You can see the Earth in the sky, and you can communicate in pretty much real time with the Earth. Mars is a whole other challenge. The journey itself. Even before colonists set foot on Mars, they'd face a grueling 6 to 9 month journey through deep space, cramped inside a vessel with no chance of rescue or resupply if something goes wrong. Unlike missions to the International Space Station, which orbits close enough for emergency evacuation, a Mars-bound crew would be committed the moment they left Earth's orbit. Any mechanical failure, medical emergency, or unforeseen system malfunction would have to be solved with only the equipment and expertise on board. Without Earth's protective magnetic field and thick atmosphere, that journey, and life on the surface afterward, exposes colonists to dangerous levels of cosmic radiation and solar particle events. Prolonged exposure raises the risk of cancer, central nervous system damage, and other long-term health problems that scientists still don't fully understand. Building radiation shielding strong enough to protect a permanent settlement adds enormous cost and complexity to any colonization plan. And if the mission includes a return trip, the whole journey could stretch to 2 or 3 years, a serious test of endurance before Mars even begins. Extreme cold Mars is brutally cold, with average temperatures hovering around -60 degrees Celsius, colder than anywhere on Earth outside the harshest polar regions. At night, temperatures can plunge even further, sometimes dropping below -100 degrees Celsius near the poles. This isn't just uncomfortable, it's lethal within minutes without proper protection. The thin atmosphere traps almost no heat, so unlike Earth, where the air holds warmth after sunset, Mars loses what little heat it has almost instantly once the sun goes down. Any habitat, suit, or piece of equipment has to be built to withstand constant deep freeze conditions, and any failure in heating systems could turn deadly in a very short amount of time. Resupply failures. Once a crew is on Mars, they can't just call for more supplies if something runs short. Every resupply mission depends on a narrow launch window that only opens once every 26 months. When Earth and Mars align correctly, miss it, and the next chance is over 2 years away. If a supply ship fails to launch, breaks down in transit, or crash lands, there's no quick fix and no backup shipment on the way. That leaves colonists dangerously exposed, since Mars offers no breathable air, no reliable water source, and no way to grow food without heavily controlled environments. A single failed resupply run could mean the difference between survival and disaster, making self-sufficiency, not rescue, the only real safety net on Mars. Life support. Failure. On Mars, life support isn't a convenience. It's the only thing standing between a colonist and instant death. Every habitat depends on machines to generate oxygen, filter carbon dioxide, regulate temperature, and recycle water. If any of these systems fail, even for a short time, there's no breathable atmosphere outside to fall back on, no backup city down the road, and often no spare parts on site to fix complex equipment. A single mechanical fault, power outage, or software glitch could turn a habitat into a death trap within hours. Unlike Earth, where a failure might mean discomfort, on Mars it can mean the crew has no margin for error at all. The psychological toll. Beyond the physical dangers, experts have repeatedly raised concerns about the mental strain of long-term isolation, confinement, and separation from Earth, with communication delays of up to 20 minutes each way, ruling out real-time conversations with loved ones. Living permanently in cramped artificial habitats under constant existential risk could take a serious psychological toll on any settlers, a factor that's often overshadowed by the more visible engineering challenges, but may prove just as difficult to overcome. So, could we just fix Mars instead? This is where terraforming comes in. The idea of transforming Mars into a more Earth-like world by thickening its atmosphere, warming its surface, and eventually making it possible to breathe outside without a suit. In theory, this could involve releasing greenhouse gases to trap heat, melting polar ice caps to release trapped water and carbon dioxide, or even installing giant space mirrors to reflect more sunlight onto the planet. But in practice, most scientists agree this remains far closer to science fiction than science fact. Mars lacks a global magnetic field, meaning any atmosphere we create would slowly be stripped away by solar wind over time. The scale of engineering required is almost incomprehensible, and even optimistic estimates suggest terraforming could take centuries, if not longer. For now, terraforming remains less a near-term plan and more a long-term dream, one that highlights just how far Mars is from ever truly becoming a second Earth. Did something already live there? For decades, Mars has captured the public imagination not just as a place we might colonize, but as a place something else might already call, or once have called, home. Long before rovers landed, low-resolution 1976 Viking orbiter photos of a mesa in the Cydonia region sparked the famous Face on Mars theory, a rock formation that, in grainy black-and-white images, looked eerily like a carved humanoid face staring up at the sky. Later, high-resolution imaging from NASA's Mars Global Surveyor and Mars Reconnaissance Orbiter showed it for what it actually is, an ordinary eroded hill, a trick of light, shadow, and pixelated resolution known as pareidolia. But the idea that Mars might be hiding evidence of an ancient civilization has never fully gone away. Some of that fascination isn't purely speculative fiction. In 1996, scientists studying a Martian meteorite known as ALH 84001, found in Antarctica but blasted off Mars millions of years ago, announced they'd found microscopic structures resembling fossilized bacteria. The claim triggered global headlines and even a statement from the sitting U.S. president. Decades of follow-up research have since shown that non-biological processes can produce very similar structures, and most scientists now consider the Martian fossil case unproven at best. Still, the meteorite reignited a question that hasn't been settled since. If Mars once had rivers, lake beds, and a thicker atmosphere billions of years ago, could life have started there independently of Earth, And could it, in theory, have even seeded life here through the exchange of meteorites, a concept scientists call panspermia? That question got its most serious update yet in September 2025, when NASA announced that a rock sample collected by the Perseverance rover might contain traces of ancient microbial life preserved for billions of years. The sample, nicknamed Sapphire Canyon, was drilled from a rock called Chayava Falls in an ancient river delta inside Jezero Crater. It shows distinctive reddish leopard spot markings alongside organic linked minerals that on Earth are commonly associated with microbial activity. NASA has been careful with its wording, stressing that this isn't direct proof of life, just a possible sign that the rock's texture and chemistry could have biological origins. After more than a year of peer review, researchers said they hadn't found a strong non-biological explanation for the pattern either, which is exactly why the case remains open rather than closed. Confirming it either way will likely require getting the actual rock sample back to labs on Earth. So no, there's no lost city, no buried spacecraft, no ancient Martian skyline waiting under the dust. But the honest version of the story is almost stranger than the myth. A planet that may have grown its own life independently at the same time ours was just getting started here, and we may be one lab analysis away from knowing for sure. The mystery of Mars. Beyond the cold, the radiation, and the endless engineering challenges, Mars holds something far more intriguing: the possibility that it once harbored life, or perhaps even hides traces of it today. Billions of years ago, Mars had flowing rivers, standing lakes, and possibly vast oceans, conditions that on Earth gave rise to life almost as soon as they appeared. Missions like NASA's Perseverance rover are actively searching ancient lake beds and river deltas for fossilized microbes or chemical signatures that could prove life once existed there. Some scientists even speculate that simple microbial life could still survive today, hidden beneath the surface in warmer, water-rich pockets shielded from radiation and extreme cold. No confirmed evidence has been found yet, but the question remains wide open, making Mars not just a symbol of danger and difficulty, but one of the greatest unsolved mysteries in our solar system. The mission that could finally answer. Here's the thing about every clue we've covered: the leopard spots, the methane, the ancient riverbeds. None of it can be fully confirmed from Mars itself. The instruments riding on rovers are built to be light, power-efficient, and durable enough to survive a 9-month journey and years of dust storms. They're good at spotting something interesting. They're not built to deliver a final verdict. For that, scientists need the one thing no rover has ever done: bring the rock home. That's the entire purpose of Mars sample return, a joint NASA and ESA effort to retrieve the sealed sample tubes Perseverance has been caching since it landed, including Sapphire Canyon itself, and fly them back to Earth. Once here, those samples could be run through instruments thousands of times more sensitive than anything that can survive the trip to Mars, the same kind of equipment used to settle debates about the ALH 84001 meteorite decades ago, but pointed at rock we know for certain came from the right place at the right time. The mission has faced repeated redesigns and budget pressure, and the return date has slipped more than once, but the underlying goal hasn't changed: get the evidence into a lab and stop guessing. Mars will also get another visitor soon in the European Space Agency's Rosalind Franklin rover, expected to launch this decade with a drill that can bore 2 meters underground, far deeper than any previous mission, specifically to search for organic material shielded from surface radiation. If life, or the chemical remains of it, is hiding anywhere close to the surface, that's the kind of depth where it would have had the best chance of surviving. So maybe Brian Cox is right that colonizing Mars won't be fun, and maybe hundreds of settlers really are centuries away. But the answer to the older, bigger question, whether Earth was ever alone in producing life, might not be centuries away at all. It might just be one sample return capsule away. So, who's actually trying to get there? This is where Elon Musk comes back into the story. While scientists send robots to quietly answer the biology question, Musk's SpaceX has been building towards something far more ambitious: an actual human mission using the company's Starship rocket, designed from the outset with Mars as the goal rather than the moon. Every major design choice reflects that. Starship burns methane specifically because methane can be manufactured on Mars itself out of atmospheric carbon dioxide and underground water using a chemical process called the Sabatier reaction. And the whole vehicle is built to be fully reusable because there's no repair yard waiting on Mars to service a rocket that isn't. For a while, the target was extremely specific, an uncrewed Starship mission launching in the November to December 2026 transfer window when Earth and Mars line up favorably, with Musk floating as many as 5 to 8 ships in that single window, each one carrying cargo, and in his more ambitious posts, SpaceX's Optimus robots to begin site prep ahead of any human crew. The pitch didn't stop there. Musk has described a scaling plan that, if everything went right, would see dozens of ships in the following window, then hundreds, working toward a self-sustaining colony of up to 1 million people by roughly the 2050s. Reality has moved slower than the announcements. Starship's 2025 test flights had a rough start, with the first several ending in loss of the vehicle before later flights improved, and the specific vehicle needed for a real Mars attempt, an upgraded design with new engines and far more payload capacity, was still working through its own testing in 2026. Musk himself has described the odds of actually making the 2026 Mars window as roughly even, and there have been reports through 2026 of SpaceX quietly reprioritizing the moon over Mars in the near term to meet NASA's Artemis commitments first, pushing any Mars attempt back by several years. As with practically every Mars date Musk has given since the mid-2000s, the safest bet is that this timeline moves. The only real question is, by how much? None of that makes Starship irrelevant to this story. Even a delayed, uncrewed test flight would be the first attempt by a private company, rather than a national space agency, to land anything on another planet, and the landing itself is far from guaranteed. Mars's atmosphere is thick enough to require a heat shield, but thin enough that it barely helps slow a vehicle down, which is exactly why every past Mars lander has needed a mix of parachutes, retro rockets, or airbags to survive the final seconds before touchdown. Starship is far larger and heavier than any vehicle that's ever attempted that landing, and precision touchdown at that scale has never been tried. NASA's own path to Mars runs through the moon first. The Artemis program is meant to establish a longer-term human presence there, testing habitats, life support systems, and deep space operations at a distance where rescue is still realistically possible, treating the moon as the dress rehearsal for the much less forgiving trip to Mars. China has stated similar ambitions, with its own crewed lunar plans this decade, and a Mars sample return mission of its own now targeted for 2028, though like every other Mars timeline in the story, these dates should be treated as aspirational rather than fixed. Musk versus Cox, two very different bets on Mars strip away the specific dates, and what's really happening is a disagreement about which kind of problem Mars actually is. Musk's public case has always been an engineering and civilizational one. Humanity should become a multi-planet species as insurance against extinction-level risks on Earth, and the obstacles in between, cost, propulsion, landing, life support, are hard problems, but solvable ones, if you're willing to iterate through enough rocket failures to get there. It's a bet on physics and money. Cox's skepticism, by contrast, is less about whether the rocket can technically land and more about the parts of Mars that no amount of engineering budget shortens. The months-long transit with no rescue option, the radiation that accumulates whether or not your ship works perfectly, and the psychological weight of committing to a place that never lets you simply go outside or come home if you change your mind. It's not a bet that the mission fails on a launch pad. It's a bet that even a fully successful mission still isn't a place you'd actually want hundreds of people signing up to live permanently. Both bets could be right about different things at once. SpaceX might genuinely land hardware on Mars this decade, proving Musk's engineering case, while Cox's deeper argument, that a place this hostile makes for a miserable permanent home regardless of how well the rocket flies, remains just as true the day after landing as it was before. Getting there and living there, in other words, may turn out to be two completely separate problems, solved on two completely different timelines. Final thought. Put it all together, and Mars ends up being two stories at once. One is about why living there would be brutally hard. The cold, the radiation, the isolation, the years-long wait for a resupply ship that might never come, and a landing that no one has ever actually pulled off at the scale Starship would need. The other is about a planet that may have quietly done something Earth also did billions of years ago, turn chemistry into biology on its own with nobody watching. Those two stories don't cancel each other out. We may not get hundreds of people living on Mars in our lifetimes. Musk's timelines have a habit of slipping, and Cox's underlying argument about isolation and risk doesn't go away just because a rocket lands successfully. But we could very plausibly get an answer to the older question long before we get a colony, whether life on Earth was ever alone in the first place. Between the methane that still won't explain itself, the sample tubes waiting in Jezero Crater, and the mission being built to finally bring one home, that answer might arrive a lot sooner than a single human footprint on Martian soil does. What do you think? Is Mars worth the risk, or should we leave it to the rovers for now? Let me know in the comments.